already assigned, but you can see this. So why I just using some names name conventions, is on the plan section on, you can see that, okay, all the slab thickness, section properties, wall thickness. So this is something I can easily handle it. Oh, what is this? Do we still have something? Let me check. Oh, still we have some wall hidden below. I'm gonna delete. Delete. We have this wall. Oh. We'll turn off that lower. Delete this wall. Let me check. Okay. Clean, right? Then turn the slab back. Alarm and go back.
Professor, just one more question for you. So, pretty much since we're done with the
Yeah.
composite beam design for now, is there anything else we're going to review right now, or are we just going to run the analysis and
Uh,
that's it?
so now, okay, is it already? Let's see. Hold on. Okay. Okay, so I think for now, I'm gonna just run it and once, and I think maybe 5 minutes I will wrap up. So, so this is about the basic and a little bit of background, and then now we're gonna run the design and see. Let me just run it. So it's already 12:30. Just I'm gonna point out just only a few, maybe two, just briefly. So first of all, just make sure that we interest all the beams has a frame composite beam design uh, modules. So I'm gonna select or assign all this composite beam design, and we just don't group it, but I'm just first run, just design it, analyze it, and design the beams. So based on the default design criteria, the ETAPs usually use one single design criteria, especially deflections. Oh, two things I'm going to point out. So this is first run. So flow beam, okay, mostly it show same size, which is makes sense, right? Because the same conditions. For spandrel beams, require, oh, okay, just flow beams has a camber typically, right? All the camber. This is just first run. The first run, we need to kind of iterate a few times to make um, our sizes really consisting based on consistent because uh, the section properties used during the analysis. But just looking at it, you could see that the flow beams and girders, 18 and 24 girder, 18 for the beams. But spandrel beam is 16, spandrel beam 16, also spandrel beam 18 here because it's worked like a girder, so it has to be heavier than the beam. Uh, but that
Quick question.
first run is based on just one criteria. Yeah,
So for the
right.
spandrel beams, did we ever specify the deflection limit of 3/8 inches?
Oh, here. So just default, go back to composite beam section here, revise the reference,
Mm-hmm.
right? Here's all the criteria based on code. We choose AAC 36010. Here, I think most of them is pretty much same, but here deflection criteria, default is L over 360. So based on this criteria, ETAPs just choose the beams, right? All the beam and girder. But inside the beam and girders, they are okay, but spandrel beams, I think we should apply more than this, right? Restrictive than this. So in this case, maybe we need to, so first of all, since this is first run, and we have to just click, this is something tutorial also, tabs tutorial explain it. We need to verify that all the members are analysis sections, since those are different, we have to say okay and the analyze it. So make, because initial we didn't size it because we're using auto select features. So ETABS choose one just medium size beam and analyze and they design it. So we need to iterate, run few maybe 1 or 2 times more. Let's run it. And but still we have to apply the different criteria along the nanometer span beams. So typically we have to run the typical conditions, cover most of cases. So now second, maybe now you could just spot check and all this, right? All the the design calculation. Now, but still the spandrel beams, they just follow that the same criteria. So that's why you choose a relatively small beam. So second run, I will choose, just turn off the alarm. I'm gonna choose all the spandrel beams. Let's see how it works. And go to design and beam view reference deflection criteria. Since 38 is pretty restrictive, 40 feet, we have 2 different cases. So we have to create another set for, because they don't have any choice. They only go by with the L over ratio, right? So 38 inches, we're using 38 inches for 40 feet span versus also 30 feet span. So this is L over so 128 on the 40 feet span. 30 feet span is likely L over 960. So this is kind of ratio we have to use applied separately. So, right, the other way, this divide by 0.375 make kind of ratio criteria we have to apply to beams. So let me back north side, which is 40 feet span criteria. I'm gonna add, instead of 360, using 120. 1280 and clear. And then I'm gonna select on this spandrel beams, assign more restrictive design deflection criteria, a 960. So that is equivalent to limited to.
Professor, quick question. So that change that you just made, that only changed it for those beams only, right? Not for everything?
Right. Not only that, spandrel beam. So let's see how ETABS can, because I checked it before, apply that way. So I specifically assigned that design criteria for spandrel beams on north and south side, and also west and this side, but the rest of beams, oh, no way.
I,
I
I
think
think
I
I
have
think when you
to do
changed it,
something the other way. Yeah,
I think when you
yeah,
changed it, it
to
changed
apply
it for
all.
all of them. Yeah.
Okay, then, but I think maybe not this way. Okay, just this. I think using override. I'm gonna choose the 360 back. How did I did it? I think, hold on, let me just run it. Because I did it, say works, I just verify it. So I have to do it in the design module. After design is done, I have to, let's see. Uh, it's not like a S frame. The ETABS has not specific. So what I did, let me just open this. So here, in here, instead of just using it, you may have to use a group, but override here. If I change this here, deflection 1280, right? I have to, so they just choose the different numbers. So I think we need to override it to select few elements. So instead of 1631, so let me just do more. Hopefully I can do this overriding maybe. Overriding. Oh, okay, revise override here. 1280. So I select those spindle beam and override it. Let me just do this and then shuffle. Uh, uh, Sign. Override it. Action 1280. And this and that. Assign. Divide. Deflection 960. Okay, let's see how differentiate those criteria to beams. Let me see, it works, right? Spandrel beam on north side and south side 24 by 55. So from 16 by 31. And I spandrel beam on the west side and south side. But also they
Well,
choose 2055. So
I have a
maybe if you
question.
click it, you see here. Yeah.
So if you go back to the framing, why? So
Mhm.
one of the spandrel beams is a 21 by no, two of the spandrel beams are 21 by 55 on the north and south side. If you look at the beams running from east to west, yeah, those.
Oh, this one. Oh,
Yeah,
okay. 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 This is something now. Okay, good point. Because ETABS, if you see this, something you should always ask yourself, oh, how come ETABS choose a different size? Uh, Interesting. But 24 by 55 was same, but I think it's somehow they receiving internally calculation moment forces might be slightly smaller. So let's check.
and
Uh,
should we reiterate? Should we just run another
Factor
iteration?
1, 301, 301. 3131. Oh, maybe you're right. Either we have, oh, it show this one because it's very close. I think it iterate for deflections. Because I think what there are a few reasons. There's some randomness, but usually ETABS choose that members based on the forces and deflection, right? But we're looking at this is supposed to be identical, but we are assuming. But internally, our when you look at the current geometry deeply, they may be identical. So it's maybe slightly off, bending moment or deflection. So sometimes it